Hello everybody, this is Victor with Primo Nutra, and we are going over the series Hydrogen, the Answer. And this is part 1. What are free radicals? We're going to go over hydrogen real quick. Hydrogen is the smallest and lightest element in existence. It contains one proton and one electron, and it's the very first element on the periodic table, meaning it is the most fundamental element. Hydrogen existed before any other element existed, and in nature hydrogen doesn't exist by itself. It usually is combined with other atoms. Hydrogen composes 90% of the universe, 70% of the human body, and 99% of the sun. So hydrogen is pretty much everywhere. Hydrogen is also the carrier for electrons inside the body, and any movement of electrons is usually accompanied by hydrogen. All sources of energy also contain hydrogen, such as carbohydrates and gasoline. Typical gasoline contains 18 hydrogens, and glucose, which is a carbohydrate that's very important in our body, contains 12 hydrogens. So you can see that more hydrogen shows greater energy capacity. So how do we create energy? Glucose is broken down into smaller molecules and taken inside the mitochondria to produce energy in the form of ATP. So NADH is the carrier that transports hydrogen and electrons broken down from the glucose into the electron transport chain. The electron transport chain are located on the inner membrane of the of the mitochondria. So if you see here the little folds that are inside the mitochondria, this is the inner membrane, and within the inner membrane there is the electron transport chain here, and NADH donates hydrogen and electrons to the electron transport chain, and this builds a gradient inside the intermembrane space, and using that buildup of pressure, ATP is formed. It drives the production of ATP, much like how a dam, the water pressure is used to create electricity. And something else that drives this process is the oxygen. The oxygen is the end receiver of the electrons, and the hydrogen, it combines with the hydrogen and an electron that it receives to produce water. So oxygen is a very important process in this as well. Without oxygen, this process wouldn't be able to go. So as you can see in the previous slide, oxygen is very important, but oxygen is also the source of free radical formation. You see the mitochondria, inside the mitochondria and the electron transport chain, there is always a little bit of leakage of electrons. And like I said before, electrons normally don't hang out without hydrogen, but when electron leakage happens inside the electron transport chain, oxygen immediately takes it up because oxygen likes electrons very much. So when oxygen takes over an electron, it forms a superoxide radical. And superoxide radicals can go and combine with hydrogen peroxide to form hydroxyl radicals, and they can combine with nitric oxide to produce peroxynitrite. The most concerning thing here is the hydroxyl radicals, which are very, very reactive free radicals. They can go and damage DNA, damage different proteins such as the ATP pump here, and also the cell membrane. So it can do a lot of damage to the cells and also the mitochondria. There are several different types of free radicals. Some are important to the body, such as hydrogen peroxide. Hydrogen peroxide is used by the white blood cells to kill bacteria and viruses. And it's sad because all this happens naturally. It's just a process that happens, that consistently happens in our body to form hydroxyl radicals. And there's nothing we can do about the formation of hydroxyl radicals. It's something that happens naturally. So this is a good depiction of how free radicals start. It starts from the electron transport chain inside the mitochondria here, and it starts to spread out, damaging the mitochondria themselves, and also different proteins and the cell membrane. We're going to go over hydrogen real quick. Hydrogen is the smallest and lightest element in existence. It contains one proton and one electron, and it's the very first element on the periodic table, meaning it is the most fundamental element. hydrogen existed before any other element existed. And in nature, hydrogen doesn't exist by itself. It usually is combined with other atoms. Hydrogen composes 90% of the universe, 70% of the human body, and 99% of the sun. So hydrogen is pretty much everywhere. Hydrogen is also the carrier for electrons inside the body, and any movement of electrons is usually accompanied by hydrogen. All sources of energy also contain hydrogen, such as carbohydrates and gasoline. Typical gasoline contains 18 hydrogens, and glucose, which is a carbohydrate that's very important. Another visualization of the oxygen paradox. This picture shows a comparison of high metabolism and high oxygen consumption to low metabolism and low oxygen consumption, and the resulting oxidative stress. You can see here, if there's a lower amount of mitochondrial O2 consumption, there's a decrease in the reactive oxygen species, meaning less oxidative stress caused by free radicals, meaning less damage to the membrane, fatty acids, DNA, and proteins, increasing the maximum lifespan. However, on the other hand, if there's a high amount of oxygen consumption, there's more oxidative stress, meaning a shorter maximum lifespan. This is another look at the free radical damage that happens. You see, normally there's an intact healthy cell, and one is exposed to oxidants, which is the free radicals, and normally there's an antioxidant network to block it off and keep it healthy. But when there is a cell with increased oxidative stress, it damages the molecules, it impairs cellular function, so the cells don't work as efficiently, and cell death, apoptosis happens quicker. There's malignant cell development because DNA gets mutated. There's tissue damage, uncontrolled cell death, which is necrosis. So, which all of these together cause disease inside the body. Damaged molecules normally have enzymatic repair of the damaged molecules. The body is usually able to heal itself pretty quickly, but the increasing the oxidative damage causes it to go more on this side. So more cells become move toward the disease state, and they can't heal themselves fast enough to stay healthy. So, in essence, the lack of antioxidants equals lots of oxidative stress. Strenuous exercise, environmental pollutants, and just respiration via oxygen, our normal breathing and living, causes free radicals to form inside of our bodies. And because we have a lack of antioxidants, because the food we eat is not fresh, we eat a lot of processed foods, we don't get a lot of antioxidants from our daily living. And also there's pollutants around. There's also electromagnetic frequencies that damage our cells, so our cells can't produce many antioxidants. So in essence, because we can't block off the free radicals, we can't take care of them by the antioxidants inside our body, there's increased oxidative stress, which leads to lipid peroxidation, DNA mutations, and cell membrane breakdowns. So oxidative stress has been linked to almost 90% of all diseases. So you can see in this depiction here, that's a lot of different diseases that are put here. So if you want to look up something in more detail about how a certain disease is linked to oxidative stress, you can write, for example, stroke and oxidative stress, or asthma and oxidative stress, and you will see tons of research data that's available. So the scientific community knows that oxidative stress due to free radicals are the cause of most of the diseases, and I think more and more people are learning about that. So this is the end of this PowerPoint section, and I hope you learned some stuff about free radicals and oxidative stress, and next week we can talk about ways to prevent it. So I hope you enjoyed it, and if you have any questions, please send me an email at primonutra@gmail.com, and I can answer your questions or go into more detail about things. So please give me some feedback, and that would be great. Thank you so much for listening. Bye-bye.